Hello and welcome to this exciting installment called Carbon Allotropes. Today we're going to be talking about the amazing element carbon and some of the different substances it makes up, like graphite and diamond. Carbon is the sixth element on the periodic table, and it weighs 12 grams per mole. It is an organic element, which means that it makes up things like flowers, people, animals, and a lot of things you use in everyday life. Carbon bonds with four other things. Its 3D structure is called tetrahedral. It looks kind of like a tripod. If you look at the 3D structure of carbon, from every way you look at it, the angle between the bonds is 109.5 degrees. The 2D structure of carbon looks like a cross. It has 4 bonds. Carbon is cool because it can bind to itself and to oxygen. Carbon is the key to life. So what's an allotrope? An allotrope is one of several possible forms or modifications of a substance. In this case, the modification is the spatial arrangement. Like we talked about earlier, some allotropes of carbon include graphite. Graphite's often found in pencil lead. Another allotrope of carbon is diamond, like in a ring.
The difference between these two allotropes of carbon are in their spatial arrangement or structure. If we zoom in on diamond to look at its molecular structure, we see that it forms a rigid matrix that can be viewed within a cube. Each carbon within this rigid matrix binds to 4 other carbons. It makes the tetrahedral shape that we talked about earlier. The angle between each carbon in this tetrahedral shape has a degree of 109.5. On the other hand, when we look at graphite, we see that it makes hexagons. Each of these hexagons form with other hexagons to make a flat sheet. These sheets are then stacked on top of each other and held together by intermolecular forces. The carbons within the hexagons bind to 3 other carbons and have a lone pair. This makes a triagonal shape with an angle of less than 109.5 degrees. So why can you write with graphite and not with diamond, even though they're both carbon allotropes? This is because diamond is very strong and has that very strong matrix that we talked about earlier. On the other hand, graphite has layers that come apart when you write because they're held together by weaker intermolecular forces. We can make the comparison between diamond being a castle with strong reinforced walls and graphite being a birthday cake that's soft and has many layers that can be peeled apart. Well, there you have it. Carbon forms 2 different allotropes, diamond and graphite. Both have different properties as a result of their different spatial arrangement and structures.